All right, using proportional reasoning. We're going to talk about means and extremes, have a little vocabulary, and use proportions to solve problems today. First of all, let's look at these. I would write these down. A ratio is a comparison of two numbers by division. All right, a proportion is an equation stating that two ratios are equal. For example, if I have 4/8, I would reduce that to 1/2. Why can I do that? Well, they're both divisible by 4, and that's a true statement. 4/8 is equal to 1/2. So I have two ratios equal to each other. Let's write a ratio very quickly. Let's write the ratio of the number of boys in here to the number of girls. Turn around and count. See if you can figure out the number of boys in here to the number of girls. So we'll count heads. Write it on your paper. Is this right? So y'all didn't count me as a girl? Thanks a lot. Y'all just totally ignored me, didn't you? I see how it is. All right, so 12 to 10. Should I reduce that? Yes, always. So what would it reduce to? 6/5. So we're about even in here. All right. Let's look at this proportion. A over B equals C over D. The reason I wrote that is to let you know that A and D are the extremes, and B and C are the means, and the cross products property gives us permission to cross multiply. Gives us permission to cross multiply. The product of the means equals the product of the extremes. The product of the means equals the product of the extremes. So that's giving us permission that we can cross multiply in a proportion. Remember, there's got to be some reason that we do everything we do in math. Why can we add the same number to both sides of an equation? Because of the addition property of equality. I've got news for you guys. Next year you will be applying the reflexive, symmetric, substitution, transitive, add, subtract, multiply, divide, all those properties that we talked about in here. You'll be expected to remember, okay? So we're adding one today, the cross products property, which gives us permission to cross multiply. All right, let's look at these as examples. The question marks mean, are these proportions? Well, the way we prove whether or not they are is to cross multiply. And so what's 2 times 4? What's 3 times 3? Was 8 equal to 9? Okay, well then that says that 2/3 is not equal to 3/4 either. That's the way cross product property works. All right, let's try this one. What's 3 times 25? 75. What's 5 times 15? 75. So yes, that is a proportion. So let's see, I told you guys, this is a super simple lesson, isn't it? Cross products property. Sometimes we're looking to complete the proportion. Just complete the proportion. All right, so what do we do? Again, we're setting up equations. That's what we've been working on now, equations and inequalities for several weeks. So we're going to solve by looking at the equation. So we're going to multiply these. That's 135 is equal to 10m. Divide both sides by 10. M would be 13.5. Talk about going back to some simple equations like we worked early in chapter 3. All right, we'll cross multiply here. 5 times x is equal to 3 times 60. Divide both sides by 5. What's x? Remember, we're using our calculators whenever you want to. Every day, get that pencil out. Get that calculator out. What's 180 divided by 5? 36. Question?
What
15 times 9, just cross multiply here. So it's 45, carry your 4, 9 plus 4 be 13. Okay, good question, good question. All right, let's continue to go on here. Cross multiply 20 times x is equal to 8 times 7.5, well, that'd be 40. Carry 456 plus 4 would be 60. Divide by 20. X is what? 3. Alright, 9 times 5 is 45. 3 times m is 3m. Divide both sides by 3. M is 15. You guys have this great button on your calculator, the fraction button, right? If I stuck that up here, 15 over 5, what would I get? I could do this in my head pretty simple. What's 15 over 5? 3. What's 9 over 3? 3, are they equal? Yeah, I can change these. I can plug them back in. Maybe not as easy over here, so I could do 3/8. Now, you can't put on your calculator, you can't use your fraction button with a decimal. You'll have to divide, convert it over to a fraction, or convert this other one to a decimal. You've got all kind of tools there you can use. All right, let's look at these. Do these in your notes. Solve for x using cross products property. Do you guys agree with 7 over here? What about 10 right here? Does that look good? Is this easy stuff? Does anybody have a question? Alright, let's get where we can look at this one. Ow. Alright. What if we have a binomial involved? We do what? What would we do with that 7? What property? Distributed. So 7 times x minus 2 equals 2 times 14. You know what people do wrong on this? What do they do incorrectly every time? On the distributive property. What do they do wrong? That's right. So be really careful. That's about the only place that folks mess up, I guess. Unless they just mess up on adding and subtracting, multiplying, dividing, easy stuff. But so we'll do the distributive property, then we've got a little 2-step equation. We've been working on these for quite some time. And so that would be 42. So what's x? It's 6. Alright, any questions? Did it work? What's 6 minus 2? It's 4/14 and 2/7. So is that a proportion? Yes. Alright, let's you try this one. Don't forget to put your parentheses around x plus 4. When you get ready, if you'll work it for us. We'll talk about that. That's a good question. Oh, yes, I would. Whatever you do. Whatever you do is fine. Decimals are good as long as you didn't have to round them. If you had to round them, you made an approximation. So why would you approximate with a decimal if you can be accurate with a fraction? You see what I'm saying? So, like 0.5 terminates at 1/2. That's fine. But if you're rounding, then just leave it in fraction form. I said there's nothing wrong with having -17/8. It's reduced, and it's in simplest form. So you could just say x equals -17/8, or you can make it mixed. So what are my possible answers? -17/8, -2 1/8, or -2.125. Now here's what I have students do. They'll do -2.1. Or -2.13. And here's my question to them. Why would you round a terminating decimal? Unless you're told to estimate or something, that would be crazy. So don't round a terminating decimal. Just leave it. Either of these three is fine. Alright. In the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open in the next 3 years? So from this, we will write a proportion and solve. Now we can do the number of stores per years, or the number of years per stores, but what makes the most sense? The number of stores per years, or the number of years per stores? What makes the most sense? Stores per year. Let's talk about independent and dependent variables for just a minute. Do you guys agree that in an ordered pair I have an X and then a Y? We're about to be ready to do some graphing. I hope you've got your graph paper ready after chapter 4 and your straight edge and all that stuff. By the way, Walmart's back in stock with graph paper. But X is known as the independent variable and Y is the dependent variable. You are a dependent. You are depending on someone for food, clothing, shelter, all your wants and needs. Okay? An independent person survives on their own. They provide for themselves. They don't need anyone else to be able to survive. In that same thought, X is independent. It can be anything. It's like time. Is there anything that we could do to slow down or speed up time? No. I mean, we may have a bad day, we may have a really good day, and I know from 2:30 in the afternoon until 7 o'clock the next morning seems to move faster than the school day does. I get that, but does it really? No. There's nothing we can do to affect time. Time's independent. It stands alone. It has nothing that affects it. But the number of stores in this case is affected by the time. It takes him time to set up and get the store going, If we're driving miles per hour, the longer we drive, the further we go, right? So what's dependent in? Okay, so if I'm talking about the longer I drive, the further I go, I've got distance and time. What's independent? I just told you. What's independent? Time. So what's dependent?
The car.
The distance. Alright, so I'm going to do the number of stores per year. And according to the first sentence, there were 232 stores in the first 2 years. And the question is, Well, how many stores will there be in 3 years if that rate, that same rate continues? And we're going to talk about rates when we talk about slope. Is that a word you guys remember, slope? By the way, how do you define slope? Rise over run. All right. Changing Y over changing X. So what did I put on top? Y over X. Dependent over independent. All right, let's cross multiply. 232 times 3 is? 696 is equal to 2 times X. Divide both sides by 2. How many stores will there be? 348 stores.
Oh,
2 years.
see that.
Look, first sentence. Past 2 years.
Oh.
2 stores. All right, good. All right, a rate is called a scale that is used to make a scale model of something too large or too small to be convenient at actual size. You ever made a model car?
Yes.
Obviously, that is not regular car size. You got to put it out on the kitchen table and get your glue all over your hands and all that stuff, right? That's an example of a scale. Also, if I would go to the copy machine, I could take a copy of your notes and I could enlarge it so that, you know, someone else might be able to see it or something. Or I could, you know, shrink it down so that I could fit several on one page. That's a definition or an example of a scale. Another example of a scale is what they use in movies. Have you guys ever seen the very first Jurassic Park?
Yeah.
You know, the guy goes in the little outhouse building, whatever, you know, the T-Rex. You remember the scene in the car when they're just being, you know, I think that's the point where they're being really still, but there's a car and there's people and the T-Rex is looking and they're trying to be still and not being
on the ledge or something.
Okay. Well, there are different ways that they tape that. And the car that they used is actually only about 14 inches long. A little bigger than a foot. The reason they did that is they've got scenes where people are in the car, a regular car, and a T-Rex head, I guess. And then they've got a scene which it's backed off of, and you're looking at a T-Rex, and people you assume are inside the car. Now, you think about taping that and how scary it would be if you had a regular car size and the T-Rex you could fit on the screen. We could just run over the T-Rex because if they were the same size, we just, you know, get roadkill out of that T-Rex. But if we got a small car, our T-Rex looks bigger, more fierce, a little scarier movie, you know. So they used a scale to make it look, you know, like the T-Rex is really big. Have you guys gone to see the 3D?
Have you seen the movie?
That's what I'm saying. Did y'all go see that? I'm not about. I couldn't do that. But how many of y'all went to see that? Did you like that? Was it great? Was it great? Okay.
It was amazing.
Let me ask you this: if a park, if Jurassic Park ever opens as a theme park, how many of y'all would go? Really? Okay, I just want to know all the dumb people, because goodness!
Definitely.
Would that not be common sense? Let's go see some live dinosaurs. You know? What? What? Come on now. Obviously, in the movie, you're in the movie, these things are going to get out. It's not a good idea. All right, so that's what a rate, a rate or a scale drawing. All right, the Ramsey Cascades Trail is about 1 1/8 inches on a map with a scale 3 inches equals 10 miles. Have you guys done some geography? You looked at the bottom. There was a scale, and it would say 1 inch is equal to 100 miles or whatever. Have you guys ever looked at a map before? Yes, you have, I hope. All right, so this is my scale here. I'm doing inches to miles. As long as I am consistent on both sides of my fraction. Over here, if I do inches to miles, over here I better do inches to miles or I'll set it up incorrectly. So that's the only thing really you have to watch. So the Ramsey Cascades Trail is 1 1/8 inches long on the map. What's the actual length of the trail? In other words, how many miles? All right, you guys have the calculator. You have the fraction button. So what is 1 1/8 times 10? Is it like 98? Is it, do you guys know? What is it? What's it say? It's what? 11 1/4. Yeah, that makes sense. 11 1/4. All right, now on your calculator, we could either multiply both sides by 1/3 or divide by 3. Is that the same thing? Is dividing by 3 and multiplying by 1/3 the same thing? It sure is. All right, so either way you want to type that in. How many miles is that trail? 11 and, what'd you say, 11 1/8 divided by 3? How much? How much? How much? 3 3/4 of a mile. 3.75. 3 3/4 miles. This is called, by the way, a complex fraction. That just means you have a fraction within a fraction, or you might have a decimal in a fraction, and you would never ever leave a complex fraction. That would be like leaving a fraction non-reduced. That's really what it is. All right, let's look on page 168 to 169. All right, these are 13 to 45 odd. These are really straightforward. 13 to 24, you're going to multiply, cross multiply, and just say yes or no. That's it. On 25 to 45, you're going to cross multiply and solve for the missing variable.